Greetings, Professor Todd Elliott. This is a video on a very simple digital to analog converter using one op amp. Okay, so on the screen, here's our circuit, and so what do we got? Well, we have a op amp like a 741 or any other op amp. Of course, it has to be biased with DC voltages, which I have not shown. So, but you will, so that it would have to be added, of course, right? You want to make sure that your voltages are sufficiently high enough, and I would do definitely a split power supply to encompass the entire output range of the op amp. Okay. So we have 4 resistors. So these are called the input resistors. And this is our binary parallel digital input. Okay, and it's going to be just like that. And I have other videos on digital if you need to review them. So the input resistors, so they will then each have their own corresponding current flowing into the summing point. That's the summing point. So all the input currents combine, add, sum together at that node. Okay? Because this is an inverting amplifier, recall that there's a 180-degree shift in phase between the input and output. Because the positive input is tied to the common ground, this point here, I have other videos that cover this, this is at a virtual ground potential, which means that summing point is virtually, not literally, at 0 volts. Now this is most important because that means then that the voltages across each resistor are referenced to that virtual ground. Okay? And because our binary input here, each binary bit is going to be 5 volts or 0. And we're assuming they're the ideal values. If they're not, there's going to could be an error. But okay, so this circuit is a very simple circuit. Yes, it works. It's just not very practical because variations in the resistor values cause errors, and the resistors have to be in even multiples. And as you get larger bit counts, you just can't get them. It's just impossible. So there's other circuit arrangements that do a much better job at that. So for 4 bits, this works just fine. I'm not quite sure what the upper limit is. Maybe 8 bits, maybe. But even then, I would use a dedicated IC for that. But that's okay. Okay, so this R5, this is the feedback resistor, and this is to provide our voltage gain AV. Okay, and it's connected between the output and then inverting input. So this is going to then receive our feedback current, which is simply going to be the sum of all the input currents, I1 through I4. And once you have that, you just use Ohm's law to find that voltage. And then once you know that voltage, the output voltage, because of the inverting amplifier, it's just the negative of that. Next page. Okay, so let's just go and assume then that, so this is going to be our LSB. So let's just assume we're going to do 2 cases here. 0, logic 0, 0, and 0. And again, this is going to be V1. This is going to be V2, V3, and V4. And then, of course, then we have I4, I3, I2, I1, IF, and VRF. Okay, so first case is we are going to let the binary bits all be 0, okay? So this is 2 to the 3. This is 2 to the 2. This is 2 to the 1. This is 2 to the 0. Okay? So they're all going to be low. Okay? Because of that, we'll get to the resistor value shortly, but if each input is at ground, the currents are all at 0. The feedback current is 0. So therefore, then we can say then that IF equals 0. So the feedback resistor equals 0. So therefore, the output voltage equals 0. Okay? All right. So now, as far as the resistor values go, so we're going to have then R1, and then R2, R3, and R number 4. Okay, so here we go. So we know from binary that the LSB, and that's the 2 to the 0, has the least impact, has the lowest weighting on the binary number, and therefore the MSB has the most impact. So therefore the MSB current, which is represented here by I4, must be the highest current, sorry. So we're going to start this out here. Okay, and any variances in these numbers will cause an error, and that's why this circuit, it works, but it's not super practical. And then this is going to be then 20. And then this is 40. And then this is 80. And you can see very nicely that the LSB, which is R1, has the highest resistance, so therefore it will have the lowest current, which is exactly what we would expect, okay? So if all the inputs are 0, there's no current, so the output voltage is 0, okay? So let's then change this to binary 7, okay? And then we're going to then, right, say, okay, we'll make this logic 1, so at 5 volts. This is logic 1, this is logic 1, and this is 0. So 1 equals 5 volts. So therefore, then I1 be 1 divided by R1, so that it's literally 5 volts and 80 k ohms equals 62 and a half microamps. I2, okay, it will be exactly double that, okay, so, and so that's 125, and then I3, okay, equals 250. Right? I4 is going to be 0 because its input is at ground. Okay. All right. So next slide then. Okay. So therefore then, the feedback current IF equals I1 plus I2 plus I3 plus plus 4 equals, so we have 62.5 plus 125 plus 250. Okay. All right. So that equals 437.5 microamps. The voltage across that feedback resistor. Now the feedback resistor voltage is determined also by the resistance, and that controls the gain. So let's just do it this way. So IF times RF. Let's just let RF be 10K. Okay, so that would be 437.5 times 10K ohms equals 4.375 volts. Okay? Because of the inverting amplifier, okay? All right, so finish this up. So let's go with binary 1, 1. So this will be the maximum extent of the range. That's the highest binary number. Okay. So the only thing we need to calculate now, because I4 is now, will have current. Okay. So that's going to be 5 divided by okay, and add all the currents together. Then we're going to add another 500 microamps in. So we had what, 62.5 plus 125 plus 250 plus 500 equals 937.5 microamps. Feedback resistor voltage. So again, that controls the gain. So this is 9.3 because of the inverting amplifier, okay? So what you're going to see then, do I have another page? Let me see. I think this is my last blank page. So what you're going to see then is that the analog output is going to be 0, and then it's going to basically stair step. Oop. Sorry, I hit my pen button funny. All the way down like this, and this would be at 9.37 volt, right? So, is that right? Yeah. Okay. So this is binary 0, 0, 0, 0, and this is binary 1, 1, 1. Now, we bias the op amp with plus minus 12 volts. This is probably going to be okay, but allowing for a couple volt saturation voltage, it's getting kind of close to it. So you really couldn't make the feedback resistor any higher than that because it would saturate. So anyway, that's the very basic digital to analog converter. I hope your day is blessed. Cheers. Bye.